Welcome to my kcse television channel, Jamarita Tribal Space High School. Kindly subscribe, click the notification bell so that you get notified once I upload a new video. Today we are looking at organic chemistry 2, that is the drawing of structures of monomers and the polymers. I have some 3 questions here. First of all, you have the first question where you have been given this monomer, you have been given this polymer. From this polymer, you are required to draw the monomer of this polymer. And most students normally are unable to draw the structures of the monomer from here or to identify the polymer. So this is what you are supposed to do. You can see, you talk of when you have been given this kind of a polymer and you want just to draw a monomer, it's just very simple, because where there is a repetition, so we have COO, CH3. Then we have this one, it has repeated here, COO, CH3, and of course it has repeated there. So of course you can also have this hydrogen has been repeated here. So where there is a repetition, you just draw the boundary from there. So we can have, we just have a monomer from here. You just draw this. Then another repetition is just here. So you draw it from this one here. So this is, if you pick it from here, this is a monomer, this one will be a monomer, that will be a monomer. When they will combine, they normally form a polymer. So if you are required now to draw the monomer from here, this is just what you do. So you have this one here, you can have this carbon here. Then in this case, we have a single bond here. A monomer should have a double bond. So you indicate the double bond here. Then we have this hydrogen like this. You have an hydrogen here. You have the hydrogen here. Then finally you have COOCH3. This is just the monomer from here. So what I've said, you just check where there is a repetition. Hydrogen has been repeated here. This hydrogen again has been repeated there. Then what you do, just have a boundary here. You have a boundary here. So this is a monomer, that one is a monomer. So the only thing you just indicate, you must have to indicate the double bond. These are a very simple structure to draw. When you come to the second polymer here, this is normally an iron. So you have been given this polymer, this is an iron, and then now you will be asked to draw the monomer from here. Where there is a repetition, we have CH2, then we have CHCN. Then we have CH2, it has started repeating here. CH2, CHCN, so there is a repetition. So what you do, you just separate this one here using this boundary. You separate this. You separate this. You separate again here. And then you separate there. So this is a monomer. This is a monomer here. This is another monomer here. When millions and millions of monomers combine, they normally form a polymer. So drawing a monomer from here is just very simple. You just have, let us have first of all have this is a carbon. Then we have this one here as carbon. Then we have the two hydrogen. So we can have an hydrogen here, another hydrogen here. So we have an hydrogen. So we have this carbon with these two hydrogen here. Then now we have this another carbon here. Between the carbon atoms, in this case, a monomer should have contain a double bond. So you indicate the double bond here. So we have this carbon here. It has this hydrogen. So you will have an hydrogen here, H, and this one here now you will have just C, and like that. That is normally the monomer. Now we have another one here, a section of a polymer, has the following structure. A section of this polymer, it has this structure. A section of this polymer has this structure. The structure starts with CH2, CH, then we have chlorine. We have CH2, then CH, chlorine, CH2, CH, then we have chlorine. Then you are supposed to, this polymer has a molecular mass of 750. So if it has a molecular mass of 750, you are supposed to find the number of monomers. To find the number of monomer in this structure, this is just chlorine. And to have a monomer from this one here, to have the number of monomers, first of all, come up with the structure of the monomer. And I have said from the two above examples that you have to have where there is a repetition. We have CH2, then we have CH, chlorine, CH2, so there is a repetition here. So you just have a boundary here. You will have another boundary here. So just come up now with a monomer from there. So if we come up with a monomer from here, we have this is a C, this one here. Then we have H2, this one here. We have CH. We can have this one as CH, and then you have this one as chlorine. I've used this condensed structure. Then now this one here, if you multiply by n, where n is the number of monomers, millions and millions of monomers which you can combine to form this polymer, this one will just give 700 and it gives 750. So from what we have been given here, carbon is 12 and we have how many carbons here? We have 1, 2. So we have 12 times 2. This one will give us, or we can just say a very simple mathematics. We have this one is 12 for the first carbon. We have hydrogen is 1 and then we have 2 molecules. Then we take 2 times 1. We have this one as 2 plus. This carbon is just 12. Then we have hydrogen here which has 1. So plus 1. And then we have chlorine. And our chlorine is just, in this case, 35.5. When this one is multiplied by n, and this one is giving us 750. So if you add 12 plus 2 plus 12 plus 1 plus 35.5, this one will give us 62.5 times n. This one is giving us 750, where n is the number of monomers. So you are supposed to get n, where n is the number of the monomers, or you can just say number of monomers normally is equals to be the molecular mass of the polymer, we divide by the molecular mass of the monomer. So, but now in this case, we have our 62.5 n. This one is equals to P, 750. So, if you need the value of n, you divide both sides by 62.5, and here you divide by 62.5. This one is equivalent to P, 12 monomers. Simple. That is simple that you can get the number of monomers from here. So these are very simple. That if you require to draw the monomers from a polymer, you just check on where there is a repetition of the units. If you want to calculate the number of monomers given the molecular mass of the polymer, you just say number of monomers is equals to the molecular mass of the polymer. Molecular mass of the polymer, we divide by the molecular mass of the monomer. Another very common question that students are being asked is the effect of the continuous use of these polymers on the environment. What is, for example, the effect of the continuous use of chlorine on the environment, or the use of this structure in the environment? You just say they are non-biodegradable or they do not decompose. So the continuous use of these polymers on the environment, you just say they are non-biodegradable. They are non-biodegradable. They are non-biodegradable. Simply means here, or you can just say do not decompose. Do not decompose. they do not decompose on the environment. So the continuous use of this one here, they are non-biodegradable or they do not decompose on the environment. And that is why the government of Kenya banned the use of the plastic bags and the plastic bags because on the environment they do not decompose, or we can just say they are non-biodegradable. You kindly follow my channel, you click the notification bell, you get notified once I upload a new video. Thank you for watching.